So I'm going to talk tonight, and I want this to be informal. So if, don't let your eyes glaze over, right? I mean, if you don't understand something, stop me and say, I don't get it. And then that gives me the chance to either say, okay, let's go into it, or say, we'll talk about that after the talk. But please, don't just nod your head. Like, I'm looking for engagement here. And actually, more seriously, the company I work with, actually, I'm working with a group of companies, and we're actually really looking for engagement. We're looking both for people who want to verify the ideas for themselves, but also for people who want to dig into the code. The code is completely open source, and it's currently being used on a couple of commercial projects. And we would really like people to engage further. We're also engaging the academic community and other sectors of the industry. For example, we had a guy by the name of David Jefferson, who's a foremost expert in electronic decision-making processes, like e-voting and such, give a security review of our approach and our architecture. So we're really looking for kind of a top-to-bottom engagement, from the requirements to the bits and the bytes. And I'm going to be talking about some of the intermediate level stuff, the stuff that makes contact with Scala. And hopefully, if we're lucky, we'll get into some Scala code. But I do have to set the stage a little bit. So essentially, the outline is really, really tiny. I'm going to introduce a few verbs. And I'm going to attempt to motivate those verbs in terms of an application context. The applications that I'll demo are not the application context I'm setting up here, and that's because I'm also using these slides as a spec for my dev teams to try to get them onto the next thing. So I have to solve multiple problems all at once. So I'm using this talk as an opportunity to lay out some of those ideas as well. But the applications that I will demo are very much along the same lines. This is just a kind of a different skin for the same application. So after I introduce the application context and a few verbs, I'm going to look at their implementation. I'm going to look at their implementation both conceptually but also in terms of code. And hopefully the code will make some sense. It will be kind of natural for you to understand and follow. And then we'll actually look at a business-to-business application that's sort of like LinkedIn, where you don't have a central entity that controls all the compute and all the storage and all the network. So in this, it's completely decentralized. Businesses can pick up their data and say, you know what, we're going over here. We're hosting over here. And that's, the application is all fine with that. And the same is going to be true of the C2C application. You can think of it sort of like Facebook, but with a distributed architecture. So there's no one centralized entity. There's no centralized compute, no centralized servers, no centralized data store, and no centralized assumptions about network and bandwidth. And then, I'll take, sort of wrap it up with a summary, and then take some questions. So let me move on at a good pace here. The verbs, I hope you will find them very natural, and they all come from one single logical principle, which is what's called in logic the law of the excluded middle. The law of the excluded middle says that a proposition is either true or it's not true. Now, it turns out in computing, especially in Scala, that law is not one that is common in the data structures that you work with or in a functional setting. Normally, you work with a variant of that. In the functional setting, you're looking that not A implies A, but you can't get A implies not A. Whereas the law of the excluded middle, which is true of classical, so that version is called Intuitionistic Logic, and that's what's in operation in functional programming, sort of in its standard form. Classical logic, which is what we grow up with in high school, right? that has the implication going in both ways. So not A implies A, and A implies not A. If you want to understand the intuitionistic version, one where you've only got one direction, think of a closure property. So you've got some set, and you've got some means of closing it up. So for example, let's say you've just got a volume, but you haven't included the boundary, right? So if you close, when you include the boundary, all right, well, when you close, if you do the closure twice, you get just the bounded entity, right? And that clearly contains the volume, but you don't have it the other way. The volume without the boundary does not imply the closed volume, right? So that's a way to think about how that principle might be, the intuitionistic version of the principle might be in play. Here, we have a very, very simple idea, absolutely straightforward. The idea is, if you're looking for A, when you come looking for A, I'm going to grab your procedure. I'm going to grab your inquiry into A. And if I don't have A, I'm going to store that inquiry away, right? And then if A ever shows up, I promise to restart your inquiry when the A arrives. So that's the constructive interpretation of this logical principle. But let's hopefully that's intriguing enough that you want to start digging into the concepts. For me, that's, if I can relate it to logic, it becomes interesting. So I'm going to illustrate this with a cartoon. Let's begin with a cartoon. Let's imagine that we begin with a really simple idea of a key value based database. Okay? And if you recall, we talked a little bit about, looking for a proposition. I begin my query for some proposition, and if I've got an A, well, then I can hand it back. There's my proof. There's my witness that I have an A, right? So you're looking at a particular location, and that location is the designation of A-ness. And that's the witness of that proposition. That's the inhabitant for that type. Now, if I don't have this value sitting here, what I'm going to do is whatever procedure that you used to get to that location, I'm going to grab it. And the way I'm going to grab it is with Scala's delimited continuations. So that's what we do. We put a reset and shift block around your probe into the query. And so your probe is now reified as a continuation. I've got it, and I can do things with it, like store it away. So what ends up happening, there's a kind of consistency in our database. The consistency is there are only 3 possible states for a key value pair. One state is that key does not exist in the database. Another state is that the key exists, in which case there are only 2 things that the value can be. The value can be a list of continuations, which are a record of all of those inquiries that have probed that proposition, or there'll be some data. And that's our consistency guarantee, right? That consistency guarantee is derived directly from the law of excluded middle. So let's try to put this idea to work. Okay, so how can we put this to work? Well, let's imagine, for fun, that we're presenting tweets, but not tweets, posts, little microblogs of a variety of characters. Maybe these are too small, but you might recognize some of those characters. There's Martin at the top, and Jason Zaug down at the bottom, and there's Tjark Romf, and a whole cast of EPFL and Scala characters. Right? So let's imagine that they all have a view that's something like this on their screen, where instead of with Twitter, with Twitter and with Facebook, the streams from all the data sources are interleaved. So you see exactly one column. But we know from literally hundreds of years of information presentation that the human brain is really, really good at spotting temporal information if you disentangle those streams of posts, right? This is derived directly from musical notation, which has now had hundreds of years, literally hundreds of years of Q&A, right? You can take ordinary kids, and within a few short months of training, they can be reading scores, which give them multiple lines of temporal information. So let's see how useful this is. Let's imagine that, that Martin here, all he does is he posts an event, and if I hover over it with a mouse, right, what I see is that he's announcing that he's getting coffee at some coffee cafe called Ladro. This is one of my favorite shops in Seattle. So maybe the team is in Seattle for some reason. And what we get is a notification that it's 5 minutes from now. So this arrow pointing in that direction means it's in the future. If the arrow were pointing in the other direction, it might be referring to an event in the past. And the bar lines here represent sort of the tempo, the passage of time, right? So what we're looking at is maybe a 4-hour scope of time. And then now let's say another character like Tiark says, you know, he's headed to Ladro in 2 minutes. And another character says, you know, I'm headed to Ladro in 10 minutes, right? And just with my eyes, with no other training whatsoever, with my eyes I can spot, guess what? They're all going to be at Ladro at roughly the same time, right? So,
with the correlation between select from where and for comprehensions? Yes, no? Okay, most of the room is nodding their head. If you're not, come and see me afterwards. If this is really going to stop you, don't be brave and say, no, I really want to understand this now. Okay. Okay, so essentially, all consumer variations of those verbs turn into for comprehensions. And in SpecialK, right now, I've been waiting for the macro stuff to solidify. Unfortunately, it's not quite. Things are not quite where I was hoping they were going to be with Scala. Still, for comprehensions are desugared by the parser. So what I really want to do, what I have right now is, for whatever these keys are, and I'll tell you what those keys are, I can compile those into the native query language of a variety of stores. So we started with base X because it was easy to give a translation to flower expressions. Direct correlation. And then we moved over to Mongo. And again, the translation is relatively straightforward. The translation, to give a preface for some of the talk, the translation to SQL is none other than data log. Actually using the basis of data log is the core. But the problem that I'm facing, if you go look at the code, by the way, if you just go to GitHub, Lighthouse is my name and SpecialK is the repo. And I think master is up to date, so you're welcome to be looking at the code as we talk. Anyway, so I compile this directly to a query in the native store, and I'd like to also compile this, but we can't right now because I need Scala to not mess with the syntax. I need this pre a certain compilation phase. So I'm still kind of wrestling with that. And, you know, I began to talk by saying we need engagement. So if anyone wants to engage on that and talk with us about some cool ideas for solving that problem, I'm all ears. But essentially, this part is going to be the continuation, right? It's the thing that gets the E. So this is essentially lambda E, handle E. And this lambda is only going to be called when something lands in this collection at that key. Okay? So that's the basic idea for all of the consumptive verbs. Right? So you can put a get here, you can put a subscribe here, you can put a read here. Right? And all of those verbs have a meaning in terms of turning this key into a query at the local store, and then checking if there's nothing there, because this is actually secretly in a reset block, we have the shift reset block. We have the continuation available, and if there's nothing there, we put the continuation there, a serialized form of the continuation there instead of the data. Okay, so, and then flipping it around, we just follow messaging style. And so collection.verb key value is what we use for the producer verbs, right? So here you would have publish, put, store, those are those verbs. Yes?
This key, is this a string?
Oh, I'm so glad you asked. Okay, so now let me come clean about what the keys are. The keys are prolog terms. So how many people are familiar with a prolog term? Okay, that's one. Two. Okay, all right. So you can think of it as essentially a generalization of Scala case classes and patterns. So without much squinting, well, with no squinting at all, every Scala case class becomes a key. Yes.
So do the key and the value share variables?
Ah, that's another good question. From our point of view, from special case point of view, the value is opaque. We have no clue what's in there. We leave that to the application programmer, so that if their query semantics is going to be related to what's in the value position, then what must obtain, the relation that must obtain, is that key is a view of value. But we don't say what that view is. That's absolutely up to the programmer. Does that make sense? Okay. But you're touching on a very, very important idea, which I'll get to when we get to the pi-calculus semantics. So the keys are prolog terms, and I can give you. Let's see. You guys don't have whiteboards, do you? Sorry, I'm a mathematician. I like to scribble on whiteboard. All right, well, maybe I'll just bring up a notepad in a few minutes and we can scribble that way. So let me escape out of this, and I just want to bring up the translation of how we do this, how this is related to pi calculus. So now I've given you two constructs of the DSL, right? The for comprehension and the put. And now I'm going to give you the rest of the DSL. Is that visible? Okay. So this one, it turns out I've got the columns of the translation backwards from your perspective, but not backwards from mine. So over here is the DSL we were just looking at. It's a variant, a slimmed down variant of that DSL. Okay? So for some pattern from some location at a given key, that's the M, run this handler. Okay? So that was the consumptive part. And here's the production part. And instead of doing the dot verb, I just put a bang here. Okay? Now is that visible to everyone? Let me see. If I move the mouse around, can you see the mouse? Okay. Alright, so the bang stands for put, publish, store, those kinds of verbs. The thing to the right is actually a structured term. For us, it's key and value. And now we can do some cool things. We can spawn, so we can run two processes in parallel, and that's how we begin to wire them up. So you could, for example, now that we know that this for comprehension corresponds to this tiny little expression here, wait at this collection for this key, and then run P, right? Or put at this collection at this key these values, Those are the two basic forms, but now you'd like for them to talk to each other. In order for them to talk to each other, they need to be able to run in parallel. Right? So that's how you wire these two up. Once you wire those two up, then you have a producer connecting to a consumer at a given location, and communication can happen. So that's equivalent to being able to take the interpretation of P and put it in its own thread, take the interpretation of Q and put it in its own thread, and let them run simultaneously. So that's the single-threaded version. I'll also show you the distributed version in a minute. I need to be able to create new locations and new collections. I need also to be able to have recursive behavior. So in Scala, the recursive behavior is, so here you can think of this as like the definition of a process. So I'm defining the process X in terms of some process body P. You don't have to worry about this stuff over here too much. All it's doing is making sure that definitions are expressions and not declarations. So once I have the definition, I immediately apply it to some value. So it's an expression like all the rest of these. It's just a notational trick. It's not a big deal. Here, the corresponding thing is X becomes an object. Its apply method the body of its apply method becomes the interpretation of the body P. Okay? That is remarkably tiny, isn't it? I can fit this whole translation on one page. If you go look at the SpecialK code base, you'll find down one branch, I wrote up this little compiler just to prove that the compilation technique works. But in general, if I were to commit myself to this as a language, that would mean I would also have to make, you'll notice there's no arithmetic here, there's no string manipulation, right? So I'd have to take on the burden of all of that. So instead, rather than taking on the burden of maintaining a general purpose programming language, which is a big deal, right? What I do is I use, and what KVDB does, is we use an embedded DSL that's embedded in Scala, that's based on this translation, right? That is an implementation of the verbs that we talked about, right? And that means that programmers can avail themselves of all of Scala as a part of, inside the DSL constructs, right? So life is a little easier than for me, and hopefully for them too. All right. If you don't understand, speak now. Okay, we're moving on then. So now, remember I just talked about that, I gave you the single-threaded version. Now here's the distributed version. So the KVDB stack, the SpecialK stack, has a JVM. Yes?
Can you maximize the screen?
Oh, sorry, yes. Is that better? Okay, cool. So the KVDB stack is a JVM together with the DSL library, together with a cache, along with some physical storage mechanism, along with some AMQP provider. So the two commercial applications that we're working with, this is Mongo, and this is Rabbit. So let's look at the interpretation of just one of those verbs, right? So the application issues a GET. The GET lands at KVDB, which checks the cache. If the cache is up to snuff, it's clean, we just hand back the data. Let's say the cache is not clean. The next thing we do is we check the store. Okay? Now, if the store doesn't contain any data, then what we do is we grab the continuation at that moment, and we store the continuation in the value place for the key. And then we do something else. Has any acquaintances, which it knows through the AMQP provider, the get is forwarded over to that node. And now it's just a get entering the system again, so we can recurse. Now, let's think about this. Let's think about this situation. If there was a put at the same key here and here, what would happen?
Sorry, we're talking about 2 different JVMs, right?
2 different JVMs. Let's say, just for fun, that this one is running at a data center in Tokyo. And, oh wait, maybe not Tokyo. How about Paris? This one's running in Paris and this one's running in London. Yeah. Okay. So now, two other processes come into play. And one writes to Paris. And one writes to the same location in London. Okay? And we have continuations sitting here and here. Oh, and there is a piece of information I neglected to let you know. The continuations that are stored here, all they do is forward back to the requesting source. That's all they do. Now, what will happen? So we have a write here, a write here. The original request is sitting here, stored here, and there's a request stored here to forward it back over to there. You'll get a race. Can you see that? Okay, so let's say, just for the purposes of discussion, that the local one, the local write, is serviced first. So this continuation is fired, and that event is handed up to that application. Okay. Then this one fires, comes back over here. What do? All we do is write the data at the location. You know what happens? The data is constantly swimming around the network. There's no actual physical boundary for the data, unless you want there to be, in which case we can tune it. But in the pristine form, it's always swimming around the network. You know what that results in? The data swims to where it's most requested. It automatically tunes to the usage patterns. Come on, guys, this is cool. Yes.
So could you restate the part about one side only storing continuation before it back?
Yeah, sure. So this one doesn't. The original request comes in here, right? We don't even want to know who the originate. We don't want, like, this could happen network hop, right? We don't really want to know what the application semantics is over here. We just want to get the data to whoever was asking for it, right? So instead of storing some complicated procedure, right, which is the application semantics, which is over here, we just say, hey, give it back to the requesting party. So application semantics has to happen at a higher level than just get input. But remember, you have all of these verbs with which to slice and dice and make up your application. We make no commitments or assumptions about what is reasonable or logical for your application consistency. The only data storage consistency that we guarantee is that in the database there will either be data or a continuation.
So that suggests that at the cost of performance, you get a fresh data.
I wouldn't say performance. That's a different issue.
The response time.
Again, that's not necessarily the case, right? Because if the application, like in the case that we're talking about, let's go back to the actual application case. Probably, they need to subscribe, not a get. In which case, the next data that comes in will be fetched as well. And the next data will be fetched. And the next data will be fetched. Again, the point is, we're not providing application-level semantics. That's for the app. We're providing a set of verbs that make you more powerful in your building of apps. Yes?
So in your DSL, you have expressions that talk about that paired up with features for the consumer.
Yes.
So do you also have expressions that are distributed?
Yes. So right. So that's exactly right. If you look carefully at the form of the DSL, it's collection.verb. Okay? And really that collection is it's a sleight of hand. I was saying collection in order to make it intuitive, but what we're really talking about is an entire KVDB, which can stand, in fact, for an entire network of nodes. All right. Does that make sense? So when you go to a KVDB, that KVDB node has a web of acquaintances.
Oh, right.
Yeah. Yes.
If the two clusters, both of them are getting get same key.
Yeah.
So in that case, there would be one winner and one loser. If the data would be on.
That's correct. There will be a winner and a loser. And the loser, the data for the loser swims away from the loser's location to the winner's location. Okay. All very good questions. Now, the next step is, how does this relate to agents in the internet? So I need to tell a little bit of a background. I also need to do time check, because I know we started late. So it's 20:09. When are we expecting this to end? It's 8:09. It's 10 after. 8:30, is that right? Okay, cool. So then, I'll tell a little story. There's an innovator down here in the Bay Area by the name of Luke Holman, and he has a company called Innovation Games. He's been looking at serious games and serious play in the corporate sector for well over a decade as a part of agile methodology. You guys have probably played planning poker, those kinds of games in order to prioritize your backlog. Okay, so Luke has kind of taken planning poker to an extremely high level. Are you familiar with the San Jose budget games? He ran those for 2 or 3 years running. All right, well, what Luke will do is, as an example, he's got actually like dozens of these games, but he'll go in and he'll, for example, let's say he goes into Apple, right, and they're looking at the next version of the iPhone. So there are all these stakeholder constituencies, right? There's marketing, there's QA, there's hardware dev, there's hardware tests, there's software dev, software test, etc. Right? And they all have a different view of the backlog, right? And so they all want to prioritize this differently. So he'll go in and he'll shirt size the backlog, right? Small, medium, large. Okay? And then he'll get representatives of each stakeholder community to a table, and he'll give them monopoly money. But nobody gets enough money to buy all the features they want. So now they have to horse trade. And what happens as a result of this horse trading is a picture of the collective wisdom emerges. And it's almost always surprising, and it's almost always better than any one individual's guess was, except for maybe Steve Jobs. There's only one of him. This is a kind of game that is, taps into something that is actually really fundamental, right? I mean, if you look at the basis of democracy is that the collective wisdom is somehow superior to the individualism. That's what we buy into when we buy into democracy. And so Luke and I looked at his games, and we looked at the state of the internet, and we said, well, look, it's very, very clear that we have all of the communication infrastructure to begin to have a wider range of ways of getting at the collective wisdom. So what we're missing is the social technology. The Robert's Rules of Order is a kind of social technology. Voting is a kind of social technology, right? We need a wider range of social technology to exploit the communication infrastructure. And games are a really good idea. So we were looking at putting his games online at internet scale, right? And then we ran smack into a problem. And the problem was identity. So let's say that there's this contentious issue, like gay marriage or healthcare reform, right? And so I live in Washington State. One of my senators is Patty Murray. Okay, and let's say Patty Murray wants to run buy a feature for healthcare reform. By the way, we actually did this in Washington, in Seattle. Then there's kind of two sides to this at internet scale. On the one hand, Patty Murray is not going to want to look at the data if she knows that in reality it's a bunch of RNC or DNC bots that are spamming the system. Right? She needs to have some guarantee that the data that she's looking at is from registered Washington voters. Okay? Now the flip side of that is that the voters might not participate if they feel like they're going to have unwanted attention as a result of revealing their opinions at that level of detail in gameplay. Okay? So you got this tension. And there's facts about personally identifiable information. The bar is very low. So there really is a tension here. And so I'm working with a group of people who, and I kind of presaged this before, who are interested in being able to have control over the quality of identity. You don't need to know exactly who I am. You need to know that what I represent or what I claim to represent is verifiable according to some source that you trust. And that's it with respect to a particular conversation. So that when we talk about agents, that's actually what we mean. This little group of folks that are working on this problem. And that's why it was so important to us not to have a central server, a central store, central control of the network. Right? That's motivating this architecture. Okay? Does that make sense? All right. So then the next step in all of this is to note that, and by the way, everything I've said up to now, right? Logical, law of excluded middle. The math is driving the design. High calculus. The math is driving the design. This next step in the design, the math is driving this design. All you have to do is go look at the 20+ years of research in security and protocols and see how this design feature falls out of things like Andy Gordon's work on the spy calculus, or Martina Botti's work on ProVerif, or Bruno Blanchet's work on ProVerif. All of these things are coming from the math. Okay, so what we do is to say that a channel, so when we talk about, remember we talked about collection and location, so that collection is actually our channel. And a connection between two agents in the internet is now a pair of channels. One for Martin to Eugene Bermico, and the other from Eugene to Martin. Okay? And behind that, behind these arrows, are two collections, just as in our other diagram, right? So when a process that is working on Martin's behalf, an agent in the internet, is listening for data from Eugene, right? That's the get operation. So there's a for comprehension in a thread somewhere. That for comprehension in that thread is listening on this channel. And likewise, there's another for comprehension. If Eugene is listening for something from Martin, there's a for comprehension listening on that channel. So does that make sense? We're associating channels with collections, but remember what I said. The collections are actually distributed over the internet. Okay. So let me try to make this a little bit more fleshed out. Just before I run the demo. So let's say that we wanted for one agent to be introduced to another agent. That turns into a for comprehension, which is looking for introduction requests at a given channel location, right? And then based on what it receives, let's say an accept, and an accept, it will confirm or deny. So this is a way to implement two-phase commit, for example, which is exactly what would be necessary if you want mutual agreement to establish a channel between two parties. So I want to show you the code for this. This is like a little tiny fragment. I want to show you the real code for this. So in general, this is the kind of code that we have developers writing. And by the way, I'm also interested in the sociological process of this, right? Like trying to get these ideas across. I've been trying to get these ideas across for better than 20 years. So these ideas are at the heart of Microsoft's BizTalk process orchestration, for example. And each iteration of this stuff, I have to look at, when I package this stuff up, what's the skill level of the developer necessary to consume it? So what we found was I was able to give this kind of DSL to Java developers, and they were able to be building distributed applications in weeks. Right? So I had Java developers who didn't have a lot of distributed application experience writing distributed applications. And this is not like, say, Twitter Storm, where the topology is much more fixed. The topology here is completely malleable, just like TCP/IP. Servers come up, servers go down. Okay, so we have Java developers without a whole lot of experience being able to build applications like the one I'm about to show you in weeks. Now the other thing that we're just about to bring online, I just want to preface this a little bit, is some Scala Annotations. I have a contractor who is porting Luis Caires' spatial logic model checker, which allows one to check properties against code. Now in this case, the code is PyCalculus code. And the properties are what are called behavioral types. Now the cool thing about behavioral types is that when developers, so here we're giving developers the annotations, which will be fed into the Scala as a part of the Scala compiler pipeline. It will check that just the skeleton code, we can't look at all the Scala code, but only the code that's actually in the DSL can be checked against these annotations. We can check for deadlock freedom. We can check for information leakage. All right. So that's what's about to come online. So let's take a look at these in real life. Hang on a second. So this application is a little bit different. I mean, in some ways, it's not even as feature-rich as LinkedIn. We just launched it in April. But the principal idea is that it functions in much the same way as LinkedIn, except that, and it's built on top of this architecture. But businesses can pick up their data and go, and still be part of the network. There's no centralized anything. At this moment, up to this moment, I didn't think about plugging Protunity, but perhaps the best thing to do is to go play with it so you can actually get a feel for it. I'm not the best person to demo Protunity, right? I work with the team on the architecture and wrote a lot of the code for KVDB, but I'm really not the best Protunity guy. I'm just realizing that now. But one of the things that we have is the ability to search, and to search the social graph. Okay? And we've had this from the beginning. So I can, well, let's see what happens if I put nothing in there. I guess I get everything that I can see within 2 degrees of separation. So now let's see, how about, I don't know, put in a software, something generic. Oh, okay. There's only one business within 2 degrees of separation for me that is looking for software. I can, here's the little connect icon. So through my connections, I can ask for referrals to be connected, just like LinkedIn, right? Except that now this goes through the kind of introduction protocol that I was showing you before, right? So that means it's completely distributed. I don't have to hit the same resource. All right, so that's a half-assed demonstration of Protunity. Please go take a look at it. And play with it. And really, what we're doing is we're looking for engagement. So if you play with it and you say, you know, I'm not getting it, or this doesn't make sense, send us feedback. You know, let us know, because I mean, this is definitely the kind. This is one level of feedback that we'd like to have.
I have a question, if you don't mind.
Yeah.
So in this demo. Can you tell me what's the data lineage or the mechanism by which you've collected the data from various networks? So I could relate that to the red and the blue networks talking to each other via the white network that you presented in the image.
So you were asking for the mechanism for data collection?
How did you collect this data into one screen, right?
Right. So
are you having 2 different networks via a centralized network?
No. So every party that enters here, because this is all about trusted business connections, they go through a fairly significant social process for uptake. So the data that's collected is collected initially through a face-to-face interview to see if you are actually a valid and trusted business, representative of such a business. And then the business provides that data through an intake process. So if that's, I'm not sure if I'm answering your question now.
You definitely explained the business value of it, but internally the mechanism by which you collected the data, like technology.
Yeah.
In the previous slides, you showed like a blue network and a red network.
Yes.
And you proved, or you suggested that the white network is the only means for them to communicate with each other.
Correct.
Does this relate to this demo that
It does, actually. So for example, right here, this screen is connected to a KVDB that is the only place which talks both to UI and to data. The data network is its own network of KVDBs. So there's a whole set, and there's only one, and those KVDBs can also talk to specialized KVDBs for business functions. For example, running the introduction protocol. But this thing is going, the forms here talk through HTTP to a server which has access to the data network but is not the data network. So it's already that architecture is in play. So we can, for example, sever this link and know that the data is secure. Right? You can't get into the data because you no longer have a way. Right? That whole network is isolated.
So by maintaining a metadata repository.
Metadata?
Repository.
Okay.
You're able to tap into various networks without actually compromising their integrity, maybe?
Metadata. Let's take that one offline, because this isn't really metadata, right? I mean, that's literally just the fact that when programmers are building these things, their only mechanism for dealing, first of all, they don't know whether what they're accessing is local or remote, right? So we completely eliminated or merged network access from local storage access. Right? They use the same for comprehensions for both, right? And then what we do is the means by which that's controlled is knowing which collection you're going against. Collection. Where a collection is really what you were calling a cluster of nodes. Yes.
So in Protunity, is the idea that every business that's part of this network runs their own server?
They can do, yeah. So they can forward it off to a trusted hosting provider, or they run it themselves. Exactly. Yeah. So fingers crossed, the individual agent works. We're still very much in the beginnings of that. So this is the Facebook-like thing. Just move along then and say, in summary, what we've been motivated by is bringing together a kind of multi-dimensional solution, right? So we've got a team of people who are paying attention to the math. Right? I'm not going to buy into it if the math doesn't work out. If I can't prove that the design has certain properties that relate to the requirements. We also have people working on and paying attention to the requirements from the point of view of the market. And our view of the market right now is that personal data is being harvested. Your data is worth billions and billions of dollars, and you're giving it away for free. And you're also giving it to parties that maybe you really don't want to be giving it to. And so there seems to be a real need to be able to manage your own data in a distributed fashion where you can have assurances about the quality of the information exchange. All right, so we have people paying attention to that. And we also have people paying attention to the application domains which will help disseminate the ideas. Because, my mom doesn't care about the pi calculus, right? What she cares about is that in her practice, her corporate engagements, that she can share information in a manner that helps her business and helps the businesses that she helps. Right? So we're looking at applications like Protunity, which will make sense to people so they can begin to move into this world. Right? So those are the kind of three dimensions that we're looking at, and each one of those actually really expands if you think about it. And the fourth thing is, we're trying to make sure that we have some fun. We're trying to make sure that not only is it significant and meaningful, but that it's a good time. That we all engage each other with a kind of light heart and with a sense of goodwill, right? I mean, one of the things I was talking. We just had an offsite sort of extreme coding session up in Denver. And one of the things I said was, I'm not trying to create a company. I'm trying to create good company. Fellowship. Right? That's what this technology is about. Enabling the potential for connection, right? Without a lot of people spying on those connections. All right, so I'm gonna leave it there, and we can go deeper in individual conversations. Any questions before I go on? Cool. Oh, yes.
SpecialK available.
Yep. It's on GitHub. You can grab it.
Is it being used in production systems?
That's what Protunity is.
Okay, cool.
That's what, yeah. And then the individual agent will go into production. I can't give any dates, but soon. Yeah. Please, I desperately need to refactor the code. I'm not going to apologize. The code sucks. I want to go clean it up. But that's why we're talking about it now, is to get bright people engaged with the code to put more energy into it. Thanks for your question. Any other questions? Cool. All right. Thank you very much for having me.